The air conditioner, one of the most life-changing inventions that man has ever built. Ask anyone from the Middle East and he'll surely agree. The modern electrical air conditioner which we have now was invented by inventor Willis Carrier in the 1980s. Now that's what you call a cool guy. Its basic function is to condition the air in the space you are in to a comfortable temperature and humidity, usually close to 22 degrees Celsius and a 50% relative humidity. Most air conditioners are made up of two units, an indoor unit located inside the house and an outdoor unit located outside the house, with copper piping connecting the two and having refrigerant fluid circulating between them. The units are basically two heat exchangers, each one consisting of a coil and a fan which exchange thermal energy between the air and the refrigerant fluid inside the coil. Inside the indoor heat exchanger, aka the evaporator, the refrigerant needs to absorb thermal energy from the room air in order to cool the targeted space to a comfortable degree. That is why it has to be at a lower temperature than the room air, because heat transfer happens from the higher temperature to the lower temperature. Inside the outdoor heat exchanger, aka the condenser, the refrigerant needs to release the thermal energy absorbed from the room air to the outdoor air in order to return back and remove more heat from the indoor air. And that is why it has to be at a higher temperature than the outside hot summer air. But that's easier said than done. How will I be able to decrease the temperature of the refrigerant before the evaporator to below indoor air temperature and then increase it back at the entrance of the condenser coil to above the outdoor air temperature without adding thermal energy to the system? This is done by refrigerant pressure variation. Increase the pressure of the fluid and it will gain temperature. Decrease the pressure of the fluid abruptly and a portion of it will flash evaporate and lose temperature. In the air conditioner, the unit responsible for the reduction of pressure is called the thermostatic expansion valve, and it is placed directly before the evaporator. It is basically a flow restrictor which forces the flow into a smaller cross-section which abruptly decreases its pressure. This decrease in pressure causes the flash evaporation of part of the refrigerant, which in turn causes the cooling as explained earlier. The thermostatic expansion valve is actually found inside the indoor unit. Therefore, after passing through the TXV, the refrigerant now is mostly fluid with a small part being vapor, but at a lower pressure and a temperature lower than the room air. The refrigerant will continue through the indoor heat exchanger, the evaporator, and will cool the room air while it evaporates more into a saturated vapor. When the refrigerant reaches the end of the evaporator, it is completely evaporated. So at this point, we have cooled the room air by acquiring its thermal energy, and the refrigerant in its saturated vapor state is on its way to the outdoor heat exchanger to dump the thermal load to the outdoor air. As we decrease the refrigerant temperature to below the room air temperature, we now need to increase the refrigerant temperature to a value higher than the outdoor air temperature by means of increasing its pressure. The unit in the AC responsible for this is called the compressor, and it is placed directly after the evaporator before the condenser. It takes in refrigerant coming from the evaporator as a saturated vapor, pressurizes it to a superheated vapor, increasing its temperature to a value higher than the outdoor air temperature to allow for later heat exchange. The compressor is actually found inside the outdoor unit with the condenser coil. The superheated vapor refrigerant from the compressor then enters the outdoor heat exchanger, the condenser, and releases the heat energy it acquired from the indoor to the lower temperature outdoors. In this process, the superheated vapor cools down and condenses back into a less hot saturated liquid refrigerant. And that is basically how the cooling takes place. This cycle will repeat until the room is at the required temperature. It is worth mentioning that at the evaporator coil, the air gets cooled to low temperatures, lower than the dew point temperature. This will cause the water particles inside the air to condense. The condensed water is collected by a tray and drained through a PVC pipe to the drainage system of the house. So actually, the air conditioner is also extracting the water content from the room air, or in other words, it is dehumidifying the room air. This is crucial for comfort because dehumidified air helps our natural biological body cooling process via rapid sweat evaporation. Achieving a humidity value close to 50% is ideal. And there you have it, ladies and gentlemen. I hope you've enjoyed and benefited from this video. See you in later videos. Don't forget to like, share, and subscribe. Hussein out.